Another measure of relative position is something called the z-score, and the z-score is just the number of standard deviations that a measurement is away from the mean. So a positive z-score means that the value is above the mean, and a negative z-score means that value is below the mean. So for example, and the formulas for z-score for sample data, it's value minus mean over standard deviation. So the difference from the mean, or the deviation, divided by the standard deviation. For population, it's x minus mu over sigma. Again, value minus mean over standard deviation. So here they want us to find and interpret the z-scores. So x is 30, s is 5, x bar is 10. So our z-score is x minus x bar over s. So that is going to be 30 is our x, minus 10 is our x bar, and divide by 5. So that's 20 divided by 5, which is 4. So that means that 30 is 4 standard deviations above the mean. And here s is 1, x bar, our x is 5, and x bar is 8. So our z-score there, again, x minus x bar over s. So that's going to be 5 minus 8 divided by 1. So negative 3 over 1, negative 3. So that means that the value 5 is 3 standard deviations below the mean. And then here, mu is 4, sigma 2, and x is 10. So this is going to be x minus mu over sigma for our z-score. So our value x is 10, minus our mean is 4, dividing by sigma is 2. So that's 6 divided by 2 is 3. So that's telling us that 10 is 3 standard deviations above the mean. So if you look at a distribution here, if this was bell-shaped data, a lot of data is bell-shaped, so let's look at bell-shaped data here. Then your mean's going to be in the middle. So our mean was 4, so 4 in the middle. And then you've got 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. Our standard deviation is 2, so this will be 6, 8, 10, and then subtracting 2, 0, negative 2. So our mean is 4, and then this value 10 is 1, 2, 3 standard deviations above the mean. So that's a picture of what the z-score of 3 is saying. So the z-score of the mean is always 0. And then, so these are x values, and these are z-scores. And then 6 is 1 standard deviation above, so it's got a z-score of 1. 8 is 2 standard deviations above, z-score 2. 10 is 3 standard deviations above, z-score 3. The number 2 is 1 standard deviation below, z-score negative 1. 0 is 2 standard deviations below, z-score negative 2. And the number negative 2 is 1, 2, 3 standard deviations below, z-score negative 3. So that's what z-scores are telling us.